Hello everybody and welcome back to our Game Engines lecture videos. And in this unit, what we are going to learn is effectively two different kinds of things. One is to learn about the basics of 3D operations in 3D space and how you can actually utilize these operations in on our Ogre graphics engine. Then we'll see how the scene graph, or rather any scene that we develop in Ogre, is organized, and how we can use different kinds of 3D spaces to operate within our scene in the Ogre engine. Once we learn about these, then we will go and start looking at how cameras, lights, and shadows are developed in Ogre. So basically, we have two major tasks to do. And as we go on in this chapter, in this unit, we are going to actually build an Ogre project. And so, again, a good portion of this class will be the lecture video on developing our application in Ogre. And we are going to use the techniques that we learned last time in terms of how to set up our basic Ogre application and how to go ahead and program in it. So, this is the rough structure of what we're going to be looking at for the rest of this lecture unit. So, first of all, in Ogre, any object that you have in the scene that you interact with and that you want to be able to work with, they are going to have some sort of representation in a container. And the containers that we have actually are basically entities. So for example, if you look at the scene down here on the right, you may have an object. Let's say in our case in the previous unit, we had an Ogre or rather a ninja mesh, and we called that an entity. We also had the same for our light. And so then each entity, what we need to do is to attach it to a node that then will have a 3D representation. So we can actually implement different kinds of manipulations on it, move it around by translating it, or by rotating it, or by scaling it up and down. And all of these nodes that we have in the scene will effectively come down and be connected to what we call a root scene node. And so each Ogre application would have one root scene node, and all of the nodes that are in the scene are going to be connected to it. You can think of these as containers, again, that hold several different kinds of actors and objects in your scene. So what we did last time, actually, when we wanted to attach our light or attach our ninja mesh into our scene, we basically called up the scene manager object, and then we asked for the scene manager to give us the root scene node, and then we attached our objects to it, to this scene node. We attached the entities, the light entity and the mesh for our ninja entity, or rather the entity for our ninja mesh. And we attach those to the root scene node. Obviously, that's not the most efficient way of going about and implementing and attaching objects to your application. So we'll see how we can actually contain and maintain locations and pointers to our objects in the scene by creating different scene nodes for them. Before we go into it, let's talk a little bit about how Ogre represents the 3D space. Okay, in Ogre, the way that the three-dimensional space is represented is if you look at your monitor, basically your rasterization of the 3D scene is going to happen something like this. So this will be your viewport that your camera is going to render, and the vertical axis the horizontal axis from left to right of your screen is going to be the direction of the x-axis, and the vertical axis from bottom to top is going to be the representation of your y-axis, and then the z-axis is going to come out of the scene. So if you have a point in the 3D scene x, y, and z, and let's say that this is my point, then if I draw a vector from it all the way to the origin of my world, then the representation of it in the 3D scene are going to be effectively x and z are going to be the two coordinates in the horizontal plane, and then the y will be basically how high up it is from the floor plane. And this is how Ogre would represent your 3D scene. Obviously, if you want to think about it, it's a right-handed axis, which means that if you put your thumb, that would basically point out. So if the thumb points out on the z-axis, then the direction from x and y would be the direction where you can close the hand. Which would create a right-handed coordinate system for us that way. So that's how Ogre represents your scene in 3D. Now, obviously, using this kind of manipulation, you will be able to notice that you can represent your scene within. So combining that 3D space representation that we talked about, we can actually combine different kinds of entities within our scene graph. So basically, the scene graph is a way for us to be able to store the information about our three-dimensional scene. So obviously, you would start with the root, which would be basically where everything is going to be parented to. So that creates the hierarchy. All right, so this is the scene that I have, and let's represent this in 3D. So I'm going to just go to the sketchbook, and so let's actually go back here on the slides. So I have, as I said, scene root scene node is basically the origin of my world, and so that is where my my Ogre basically thinks of and basically takes as the world origin or world center. And then for every entity or for different kinds of objects that I want to create and to move around, I will basically create scene nodes for them and then attach these entities to those scene nodes. And then I make these scene nodes to be the child of one another or the child of my my roots. So in this particular scene graph that I have established here, what I'm doing is I've got this root basically at 0, 0. Then I have another node that is on the x, y, and z. So as if you remember, x, y, and z are the first and the second and the third component of my vector. And so then again, x is to the right on your screen, y is upwards, and then z points out towards the camera. And so that's how the coordinates in Ogre are represented here. And I can manipulate these scene nodes through the parent-child hierarchies that I have. So I have one scene node called scene node 1 in this particular scene, and it is located 10 units along the x-axis with respect to the root scene node because it's parented to the root. And as you see here, the parent-child relationship is denoted by the arrow. Then there is another entity, entity number 1, which is placed inside of the scene node. So the entity 1 is parented to the scene node 1. Then I have another scene node called scene node 2 that is located at 10 units on the y-axis and 20 units on the z-axis with respect to the scene node 1, because scene node 2 is parented to the scene node 1. And then entity number 2 is actually located on it. And obviously I have the locations or the positions already filled for you, but we're going to work this through. So let's take a picture of this graph here and then represent it in and then try to draw it out. Okay, so I brought this representation for my scene graph here for you to see. Now, so how do we represent this? So my origin, my root is going to be at the center of the world. So if this is my origin, actually it's ball point. Okay, so this is my origin, and so that would be the root. And so it is obviously located at 0, 0, 0. Now, how does my axes? How do my axes represent? So the axes are kind of like this: x, y, and z for my world coordinate system, right? So the scene node, let's call it R, which is going to be there. So this is my root scene node. Then I have a scene node number 1, which is going to be actually parented to the root. So all of the relationships in terms of rotation and position and scaling is going to be with respect to the parent, its parent, which is the root. And it's with respect to its parent is 10 units and 0 units and 0 units, which means that you go 10 units to the right and nothing upwards and nothing out, and so that would be your scene node 1. Let's call it n sub 1. So the n sub 1, its location, its position is going to be 10, 0, 0. And then again, it is going to be with respect to its parent, which is the root scene node. So if you want to think about it, there is kind of like a string attached between the root and node sub 1. So if root moves about, the node sub 1 is going to move about with it. And later on, we'll see how we can actually utilize this concept to be able to make transformations with respect to the parent nodes and the child nodes and things like that. And so let's say that you have a ninja, so a ninja entity. And this is my representation of a ninja. And that entity is going to be attached to scene node 1, which basically makes the ninja to be placed at its node, scene node 1. So then in this scene graph that I have here, I have scene node 2. And the scene node 2 is actually located 0 units on x, 10 units on y, and 20 units on z, right? But this is not going to be 0, 10, and 20. So this is not going to be where the node 2 is, because node 2 is parented to scene node 1. Then what's going to happen is that this 10 units and this 20 units would be with respect to scene node 1. So if I were to draw this with the green light, then the scene node 2 is going to be 10 units upwards from scene node 1. So its y is going to be 10. Its x is going to be 0. And then its z is going to be 20 units this out way. So it's going to be 20 units, its z, with respect to the scene node 1. So its coordinate system is going to be 10 units that way, and then 10 units, 20 units this way, and then 0 units on the x-axis. So therefore, its location is going to be 10, 10, 20. Alternatively, if I were to represent the node 1 as a vector at 10, 0, and 0, so this is going to be my vector, then so this is going to be n sub 1 x, n sub 1 y, and then n sub 1 z. And n sub 2, its vector would be 0, 10, and 20 in its n sub 1 coordinate, so its parent, actually. its local coordinate with respect to its parent is that, which makes the global coordinates of my n sub 2 with respect to the general scene node to be basically n sub 1 plus n sub 2 in n sub 1 coordinate. So that would give me 10, 20, 10, 0, and 0 plus 0, 10, 20, which will be equal to 10, 20, 10, 10, and 20. So that would give me the world location of my node 2 with respect to the original scene node, which is the root. So then this basically, the location for entity 2 is going to be the location of its scene node added to the location of its parent scene node. So you basically keep adding the parents until you reach the root node, and then you'll get to the location of where your child scene nodes are positioned. Okay, and now let's take a look at our application that we had created earlier, and let's try to play with this. And first of all, we are going to go ahead and look at how our objects are represented. I'm going to draw these out for you as well. And then we are going to create scene nodes for these different little objects here and there, and make them their own little container. So first of all, let's take a look at the first two lines that we have here. So when I create the scene, I'm going to create an entity pointer, and I call it my mesh. And this entity pointer is getting the, or rather is being created, so a ninja mesh is being created for it. Then what I'm going to do is I'm attaching on line 12 here, I'm attaching this object, this entity that I have, directly to the root scene node. So if I were to draw the scene graph to my root scene node, so basically if this were to be my my axis, x and y, and then I'm going to make the z-axis to kind of point outwards, then the ninja is directly placed at the scene node. So basically this is going to be, the ninja is going to be at the root scene node. So there's one limitation with this, and that is that my object, I won't be able to move it. If I wanted to move this object about, I would actually have to move its container or its scene node about, which means that I have to manipulate my root scene node, and this is not obviously the way to go. So same thing with the lights. We're going to fix both of these in code now. Okay, so let's go ahead and let's comment these out. So I'm going to create a scene node, and well, before actually we do that, let's actually add the Ogre namespace so that I don't have to type in Ogre namespace resolution all the time. So we're just going to go ahead and create a scene node pointer, and let's call it ninja node. To do that, we will get the scene manager, and we call its create scene node method, and ninja node will be my node. If you look at your textbook on page 20, the textbook is not using the namespace, so you would see ogre colon ogre colon before the scene node there. and all these other entities that we have there. So in order for us to kind of, you know, a little bit faster typing things out, I'm adding the namespace up here on line 3. So that's the only difference that I have here with your textbook. So so fantastic. I created my node 1. Then let's go ahead and add this node as a child to my my root. So I'm going to call the M scene manager get root scene node, and then use the add child attribute to add this node to it as a child. And so the node that I'm going to add is going to be Ninja node. Let's comment this out. This is the scene node. Then setting up parent-child relations. Now, obviously, I want to create my ogre entity. So I'm just going to copy that back and create an entity, and then I'm going to call it my mesh, and it's going to be basically a ninja mesh, and it's called my ninja, and so the ID is my ninja, and the name is ninja mesh. Now that I have this ninja entity, I can attach it to my scene node, which was the ninja node. So I say ninja node attach object my mesh. So then again, I'm going to comment attach the ninja entity to the ninja scene node. Fantastic. Let's compile and make sure that it works. All right, and here we are. So the project should look fairly similar. There's nothing really that has changed. The only difference now is that the ninja mesh that I have here is not attached to the origin of my world. So it is actually placed within its own scene node. So I can now take this node and move it around and work with it. So for example, let's actually do something really simple to it. Let's make this ninja a little bit smaller. All right, so let's scale the ninja a little bit down. So in order to do that, I will basically perform my operation on the ninja node. So ninja node is an entity pointer. I'm going to call it up, and then, or rather, as a scene node pointer, and then I'm going to do a set scale. And then in the set scale, I want to pass to it a vector 3D. Actually, I can do it two ways. I can either add a vector 3D as a scale, or I can give it real numbers, x, y, and z. So let's do it with numbers. So let's scale it up at 0.5. So this is going to basically scale my ninja half size uniformly. Let's compile and build this application one more time, and now the ninja should be half the size of its, effectively half of its original size. And voila, here it is, half of its original size. So now let's create another ninja, and let us place it to the right of the first ninja. So if I wanted these two ninjas to be placed in two different entities with no relationship with each other, I'm going to basically create a scene node, and I'm going to attach that scene node for the second ninja to my root. If I wanted the second ninja to be attached and be the child of of the first Ninja node, I would add child to the first Ninja node. Let's talk about it. Let's program it and let's see how it looks like. So let's create another scene node pointer, and let's call this one actually. I think we can use an ogre head. So ogre head node m scene manager create scene node. Let's call it ogre head node. And then let's attach it to the root, get root scene node, and then add child ogre head node. Let's create an entity pointer for my ogre head, MC manager, create entity, let's call it my ogre head, and then the mesh for it. I don't remember where the ogre head mesh is. That's fairly easy to find out. Let's go ahead and dig in our application. So we're going to go to C drive, gaming programs, ogre, and then media, and models. And it is basically called ogre head. And so we're going to basically type in ogre head.mesh. Now that we have this ogre head entity created, we're going to basically attach it to the ogre head scene node we created. So ogre head node attach object my ogre head. All right, now if I actually run this application, the ogre is going to be exactly at the same location where the ninja is. Actually, let's take a look and let's see how it looks like. All right, so the ogre head, as you see, is kind of sort of at the center. So that's what I was talking about. If we were actually directly attaching these to this root scene node, that would be basically stuck there. Now that we have their nodes, let's move the ogre head a little bit to the right of the ninja. So we'll use the set position on the ogre head. So ogre head node set position. And then in the set position, I can either give it a vector 3. This time it's actually, let's use a vector 3 object. So vector 3 is basically a data type in Ogre. And so let's move it 10 units to the right and no units on the Y and Z axis. So 10 units to the right is basically the X will be 10, and then the Y and Z will be 0. So we'll run this app one more time. And now the ogre head should be shifted to the right with respect to the ninja. Okay, now 10 units was pretty small, obviously, so let's move it a bit more. Let's move it 150 units. All right, so 150 units is actually pretty good. Now, if I move about, you would see this is how these objects are basically created. And so they are actually in the three-dimensional world, but the root of my scene is basically, or the root scene node is at the feet of that ninja. And I created the two scene nodes to make them move about, to be able to actually manipulate each of these objects independently. All right, now that you've seen how to scale and how to translate with using the set position and set scale methods of a scene node, let's look at rotations. Rotations are a little bit different in that in scale, you have the X and Y and Z axes of your scaling. And then in translation or setting positions, the position also has its X, Y, and Z axis for its transformation. The rotation of your scene nodes can be done two different ways. You can either call up the set rotation to be able to physically set the rotation of your object, or alternatively, or rather the scene node, or alternatively, you can actually utilize three different rotation mechanisms or methods that each make a rotation along a specific axis of your object. Namely, you can set the pitch, the roll, or the yaw of your object. So let's take a look at it and let's see how it looks like. So I'm going to create another node here, and I'm going to call this Sinbad node. Actually, while we are here, let's go ahead and move the Ninja node and let's move it negative 250 units on the X and Z, on the X-axis. Let's compile and run. Make sure that we get a good picture of where these different objects are located. So this shows you also an alternative way of setting positions, either by setting X, Y, and Z separately, or by setting them with a vector, or rather a vector 3. So now let's go ahead and create another scene node. I'm going to create a scene node pointer. Obviously, some of you may have a question, why am I creating scene node pointers as opposed to scene node variables? There are several software engineering reasons behind it. If you create a scene node, then you would have it in a container. It's going to be a variable, and it's going to occupy space in the function stack. And the function stack is a very precious commodity. We don't want to really overuse it. One of the reasons that we use them or we declare these as pointers is when you do this and you create your scene node by calling mSceneManager or create scene node, it's going to allocate the memory from heap. And heap obviously is a much, much larger memory unit that you have, and it's also allocation is dynamically created. So whenever at runtime you want to get rid of these scene nodes, you can actually delete them. Whereas creating a variable, then they would be stuck in the function stack until you are within the create scene function. So these two are the two main reasons that I'm creating these as scene node pointers. So let's call this Sinbad node 1. Create scene node. So let's call it Sinbad _1, and the mesh is Sinbad.mesh. Then we're going to attach this node as a child to the root. And I called it Sinbad node 1. I misspelled the scene node. Then I'm going to create an entity. Yes, I didn't do it right. So Sinbad 01 node, and then these guys go to my entity. So that's my scene node. Then I'm going to create another entity pointer. Call it my Sinbad ent 01, and that would be an mSceneManager create entity. Now this time I can add these, and then go ahead and use the Sinbad node 1 attach object. And it would be my Sinbad entity 1. All right. So then again, what I did is just what we did with the ninja and the ogre head. I created a scene node, called it Sinbad01 node, and it's basically a Sinbad node 1. Then I added it as a child to the root scene node. Then I created an entity from the Sinbad mesh, and then I attached that entity as an object to Sinbad node 1. And we're going to make this scene node rotate about by using pitch, roll, and yaw methods for this. All right, so obviously the Sinbad is pretty small. So let's actually fix that problem real quick. So we go and do Sinbad node 1, and then set scale. And let's make it 10, 10, and 10. Okay, much better. So my Sinbad is now placed at the center of the scene, and obviously I haven't moved its position, and I just scale it up to be 10 times on X, Y, and Z. All right, so now let's go ahead and create another set of these Sinbads. All right, so we're going to create a Sinbad node 2, and we're going to make this Sinbad02. If you don't change this and then you won't have unique IDs, you're going to get a runtime error. Then I'm going to create this and attach it as the child to the root, create another entity, and then let's call this Sinbad2. And then we're going to attach the Sinbad entity 2 to our Sinbad node 2 and scale it up. Then we're going to move the Sinbad 2, and we're going to move it upwards. So Sinbad node 02, actually node 2, and then set position vector 3. And so let's do 100, 100, and 0, and 0. So we're going to move it 100 units upwards. Actually upwards, so that would be Y. Okay. And let's compile and run this code. So now I should have a Sinbad at the center, and then the second one should be moved upwards vertically. All right, that's perfect. So the second Sinbad is the one that's kind of placed upwards. So then let's rotate the second ninja by changing its pitch. So let's go ahead and use the Sinbad node 2, and then pitch. Now pitch will take basically you can give it two different variables for its transformation. The first variable is the angle of pitch, and then the second variable is its transform space. We're not going to touch the transform space yet. We're going to get back to it a bit later. But right now, let's give it about half pi radians. So I'm going to use radian structure, and then math half pi. which is basically 90 degrees, if you want to think about it. So what I'm going to do is I basically use pi over 2, just half pi, and then I pass that as a radian variable to the pitch of my Sinbad 2. So it is going to basically rotate my second Sinbad effectively along its pitch axis by pi over 2 degrees, or rather 90 degrees, or pi over 2 radians. Let's see how it looks like. So the pitch is basically, if you want to think about it, it's kind of like a line of a horizontal line going through the Sinbad, and then it's basically rotated along the horizontal axis, or along the x-axis, 90 degrees. So that's how your Sinbad is actually kind of looking downwards. So the one that on top is basically your pi over 2 degrees pitch. So let's go ahead and now create a third Sinbad. And create Sinbad 3, and then Sinbad node 3, and then Sinbad entity 3. And then we're going to attach this entity to Sinbad node 3. Then we're going to make some transformations on Sinbad 3. So we still scale it 10 times to make it bigger. Then let's move it negative 100 degrees. And this time, let's use the roll. All right. So now the roll basically is as if I had translated my Sinbad along its z-axis. So if you think about a point going outwards towards you, towards the camera, out of the monitor, and that would be the axis, then roll is basically rolling the Sinbad along the z-axis, which is kind of the axis that's coming out of the monitor, and it's rotating along that axis. So that's how the roll worked. And so let's do the yaw on the first Sinbad. So let's go ahead on the first Sinbad, which is basically Sinbad node 1. And then yaw. With it pitch, with it roll, and we're going to do yaw now. And so that would be going with radians, math, half pi. And then compile and run. Okay, and so yaw is then rotating your Sinbad along the y-axis. So it's going to, if you think about an axis going upwards, then yaw is the rotation around the y-axis of your scene. So pitch is rotation along the x-axis, roll is the rotation along the z-axis, and yaw is the rotation along the y-axis. Now you might want to say, ask why did we use radian? Can we just use degrees? Obviously you can. So if I go ahead and change this to degrees, then I won't have to pass 90 pi over 2. I can pass to it 90. And that would have the same exact effect as rotating the middle Sinbad along the y-axis, or for its yaw at either pi over 2 radians or just 90 degrees. So obviously visually there's no difference. It's just two different ways of using the yaw input parameter. Okay, so this is, I think, a pretty good chunk for you all to start working on and get a little bit familiar with as the first portion of this lecture video. And so in the next portion, I'm going to talk a little bit about different kinds of spaces for your transformations in terms of your parent space, your local space, and your world space. And then we are going to take a look at how we can actually set up your scene graph a little bit more cleverly. And then once that is so in the next lecture video, that's what we're going to actually do before we go into the concepts of cameras, viewports, lights, and shadows in Ogre. So I close this lecture video portion here, and I'll talk to you in the next video.